Assalamu alaikum, girls. In the previous lesson, we have talked about the periods and groups in the periodic table. Today, we will complete our objective, which is number 2, and figure out what are periods and groups in the periodic table. We will find out exactly how are they made. First, there are 8 groups in the periodic table. Now, group is a column. So this is column number 1, column number 2, or group 1, group and 2. Then it will split. And then you will jump to group number 3, 4, 5, 6, 7, and 8. The scientists, they put the elements in orders of their groups because they have similarity in the number of electrons in the outer shell. What does the outer shell mean? The outer electrons. Look here. I have lithium, sodium, potassium. They are in the same column or in the same group. Why? Because here, if we distribute the electrons, lithium, it has 3 electrons. If we distribute the electrons of lithium, we will find out that the outer shell or the outer orbit, it has 1 electron. Going to sodium, it has 11 electrons. So first shell, 2 electrons, second shell 8 electrons, and the last shell 1 electron. Going to lithium, as you can potassium, as you can see, it has how many electrons in the outer shell? It has 1 electron in the outer shell. So in the same group, the elements, all the elements have the same number of electrons in the outer shell. So because they have only 1 electron in the outer shell, they are in group number 1. So the group number equals how many electrons in the outer shell. Okay, so all these have 1 electron, so they are in group number 1. Let us have another example. For example, group number 5, nitrogen and phosphorus. We said the number of group is the number of electrons in the outer shell. So we figure out that because nitrogen and phosphorus are in group number 5, it means that they have 5 electrons in the outer shell. And this is true. Look here. This is the nitrogen. طبعا you have to know how to distribute the electrons. Nitrogen, it has 5 electrons in the outer shell. Actually, it has the total number of electrons for nitrogen is 7. And this should be given for you by the periodic table. You should not memorize this. So nitrogen has 7 electrons. The first shell, you will put 2 electrons. And then the outer shell has 5 electrons. Same goes for the phosphorus. The phosphorus, we said it is like the nitrogen. It is in group number 5. That's why it has 5 electrons in the outer shell. Type, let us have an example for group number 6, oxygen and sulfur. It means they are in group number 6. It means that they have 6 electrons in the outer shell. Let us find the electronic configuration for sulfur. Sulfur, بما إنها it is in group number 6, so it has 6 electrons in the outer shell. 1, 2, 3, 4, 5, and 6. Okay, same goes for oxygen. They are in the same group. 1, 2, 3, 4, 5, 6. Okay, so oxygen and sulfur are in the same group, group number 6. It means it has 6 electrons. Nitrogen and phosphorus, it's in group number 5. It means it has 5 electrons in the outer shell. Look at the carbon. 1, 2, 3, 4. It has 4 electrons in the outer shell, so it is in group number 4. There are names of the groups and there are numbers. They always, in the periodic table, they always use the numbers, the Latin numbers. This is number 1, 2, 3, 4, زي 17 العربي, and then 5, 6, 7, and 8. Each group has a name. Group number 1, these are the names you have to know. Group number 1 is the alkali metals. Group number 2 is the earth alkali metals or alkali earth metals. Both are correct. Group number 7 are called halogens. It has fluorine, chlorine, bromine, iodine, and so on. Group number 8, or it's also said to be group number 7, it is called the noble gases. Why are they called the noble gases? Because they are not reactive at all. They have 8 electrons in the outer shell and they will not react. They are stable elements. That's why they are called noble gases. Now, talking about the reactivity and how fast they react in a reaction, group 1 and 2 are metals and they are the most reactive elements. While moving from left to right in the periodic table, the reactivity decreases, and moving from up to the bottom of the periodic table, the reactivity increases. Yani, francium is the most reactive element. Lithium in this group, lithium is very reactive, but compared with its group is the least reactive. So going down the group, reactivity of metals increase. Going to the right of the group, the reactivity decrease. Okay, you have here this trend in the reactivity of metals. The metals, as you go to the left, they will increase. Yani, the reactivity of group number 1 is more than the reactivity of group number 2. For example, the reactivity of lithium is more than the reactivity of beryllium. So going this direction, the reactivity of metals increase. But in the halogens, the trend is upside down. Yani, we said that the metals going down, the reactivity increase. For halogens, it's the up way round. When you go up the group, the reactivity increase. And you have this written in your book here. You have the halogens, as you go up, the reactivity increase. While for first group, lithium, sodium, potassium, and so on, as you go down, the reactivity increase. So group 1 and group 7, they are upside down. Now let us talk about periods. Remember, the groups, we said that the number of electrons in the last shell, it's the group number. The periods, it's different. The number of shells, how many orbits, how many electrons, how many shells equals to the number of the period. For example, here, the first shell is the hydrogen. It has only one shell, one orbit, so it is in period number 1. Look at the second shell. The second shell, or the second period, it means that the atoms, the elements have the same number of what? Of shells. Carbon has 2 shells. Nitrogen has 2 shells. Oxygen has 2 shells, so going in a row, they have the same number of shells. Going in a column, they have the same number of electrons. In the third shell, they have 3. In the third shell, yani the third period, they have 3 shells. Okay, so it's here. Period number 1, it means 1 shell. Period number 2, 2 shells. Number 3, 3 shells. Number 4, 4 shells, and so on. Okay, so go here. Helium and hydrogen are in the same period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, they are in the same period, and so on. Period number 3, 4, and 5, and so on. There's something you have to know, that moving across a period, each successive atoms of the element gains 1 proton or 1 electron. For example, we said here carbon has 2 shells, but it has how many electrons in the outer shell? 1, 2, 3, 4. طيب. Go to nitrogen, it's in the same period. How many electrons does it have in the same period? How many electrons in the outer shell? 1, 2, 3, 4, 5. So it gained 1 electron. Here it will gain another 1 electron. It becomes what? 6. 1, 2, 3, 4, 5, 6. So going from left to right in a period, the number of electrons will increase by 1. Okay, again here I have phosphorus. Phosphorus has 1, 2, 3, 4, 5 electrons in the outer shell. 1, 2, 3, 4, 5, 6 electrons. What are the trends in the same period? Metals on the left going to non-metals on the right. As we said, here on the left are the metals. On the right are the non-metals. Okay, group 1 element are the most reactive metals. This is, you have to memorize this. Group 7 are the least reactive metals. And as you go from right to as you go to the right, the reactivity decreases, as I just said. When you go from left to right, reactivity decreases. Now, elements in the same group, because they have the same number of electrons in the outer shell, they have the same properties, the same chemical properties. The relationship between the group number and the number of electrons in the outer shell are the same. Okay, that's why in group number 1, it means that they have 1 electron in the outer shell. They can give out, they can lose this electron. Now losing this electron will make them more stable. Look here. Here. Now for lithium, if it loses 1 electron, it will have 2 electrons in the outer shell, which is stable. For sodium, it is reactive to lose this electron, so it will have 8 electrons in its outer shell. For potassium, it is very reactive because it wants to lose this electron to have 8 electrons in the outer shell. Yani it is all the metals and the non-metals, they want to reach stability. What is stability? Either having 2 electrons in the outer shell, or the first outer shell, or 8 electrons in the second and third. They either tend to have 2 electrons or 8 electrons. All the elements act the same to have this stability. Now losing an electron will make an ion. What's an ion? Ion, it means an atom with a charge. Now I think you know this, that any atom that loses an electron, it becomes positive. Any atom that gains an electron, it becomes negative. So here, it loses an electron and it is positive. So the valency for lithium is +1. Sodium, it loses 1 electron, and because it loses, so it is positive. So also the valency here is +1. So what we conclude is that the number of group equals to the valency. Lithium, sodium, potassium, rubidium, cesium, and francium, all of them, they have +1 valency. It means they lose 1 electron. Beryllium, magnesium, calcium, and so on, they all have +2 valency. It means that they tend to lose 2 electrons. Type, go here. In group number 3, they have a valency of +3. It means that they tend to lose 3 electrons to reach their stability. For group number 4, they mainly share their electrons. وهذا اللي بنسميها covalent bond, الرابطة التساهمية. Here, they are in group number 5. 5, it means they want to gain 3 electrons. So 5 plus 3, it will become 8. Okay, so they tend to gain. That's why it is negative. When they gain more electrons, and the electrons are negative, so the negative the valency is negative. In the group number 6, they want to gain, they have 6 electrons in the outer shell, so if they gain 2 electrons, they become 8. That's why it's -2. In the halogens, they have 7, group number 7, they have 7 electrons in the outer shell, so they tend to gain 1 electron to reach 8. So it's -1. Here in the noble gases, it's always 0 because they will not react, they are stable. That's why they are called noble gases.